Hello, today we will be creating function tables. So we already focused on identifying functions, so now let's create some tables. Again, we're still in Unit 4, creating function tables. I'm on page 63 to 64. Okay, our objective today is to create function tables, and then how do I create a function table? Go ahead and pause the video to make sure you have the topics written down and the table of contents filled in. So let's quickly review. A function is a relationship where each input has exactly one output. Remember, that means x cannot repeat. So if you think of function tables like a machine, okay, something goes in and then something comes out. Okay, a function must be in the form of y equals mx plus b. We call this slope-intercept form, and we are going to be learning more about that later in the future. So the x gets input into the equation, and we would get the y. A way to remember this, so the input we would say is known as the domain. The input, or it's all the x values, while the output is known as the range, the output, and all the y values. So an easy way to remember that is Dix-Roy. Okay, think of it like a name, and then that should help you remember what those are. So I'm just kind of going over this before we get started on creating our function tables. So if I refer to domain and range, the domain is all the x values, and the range is all the y. When we want to tell what the domain and range is, we have to write them in order from least to greatest. So if I'm just looking at the domain, I kind of wrote them out, and you can see, all right, they're already in order. So I can just write them down. And then we use brackets to represent them. It's stating that they're a set of numbers. So I'm going to do the same thing with the range. So for the range, I have 5, 0, -3, -4, -3, 0, and 5. Okay, and we're only going to write the numbers once if they repeat. And I'm going to look for my smallest number first, which is -4. So I've got -4, -3, then I see 0 and 5, and I'm only going to write them once. Okay, so my range would be -4, -3, 0, 5. So you have to remember to write them in order from least to greatest. A lot of times that's what people get wrong. Okay, same idea if we are looking at a graph. The x is our domain, and then the y is our range. So we're going to focus on the domain. It's a little easier to write in order from least to greatest, so we'll see that a and e fall on -2, so our smallest number is -2. That also tells us this is not a function. And then I've got 1 and then 3. Okay, meanwhile our range, we'll start to the bottom because I want the smallest first, is -4, And then I've got -1, 2, and then 3. And we write them as a set of numbers. So it's important to know what domain and range is, or input and output, or X and Y, so that way as we create our tables, we know where the numbers should go. So let's start working on creating a function table. So you'll see it gave us some input numbers. Okay, so we're going to start with 1. So that means number 1 is going to go into our function machine. Here's our rule, and then we're going to get an output. So the way we set this up is we just show a little work. So our rule is y equals 3x plus 2. And so we take the numbers and we plug them in to get y. So we get y equals 3, and we evaluate the given numbers. Okay, so remember we talked about evaluating earlier in the year. So I'm going to do 3 times 1, which is 3, plus 2, which is 5. So that means if 1 is my input, my output is 5. And that creates an ordered pair, 1, 5. Okay, so now I'm going to do the same thing with 2. So I get y equals 3 times 2 plus 2. So 3 times 2 is 6, plus 2 is 8. So my next output number is 8. Okay, so then that ordered pair is 2, 8. Remember, these are just the same things as x and y. Okay, so now I'm going to input 3. So I've got y equals 3 times 3 plus 2. So 3 times 3 is 9, plus 2 is 11. So y is 11. And hopefully, once you do 3 numbers, you should start to see a pattern. So if my next input value is 4, what do you think the output's going to be? And hopefully you're recognizing that these are increasing by 3. So 11 plus 3 would be 14. Well, let's check that. 3 times 4 would be 12. 12 plus 2 is 14. So from there, we should be able to fill in the rest of this table. So one thing about function tables is that they always have a pattern. So I'm going to get 17, 20, 23, 26, 29, and then 32. So there's our first function table. Okay, let's look at another example. All right, so here, this is slightly different. Now, the solution is the same thing as our y value, or our output. We have our rule up here, and then down here it says substitute values into the equation to get an ordered pair. Graph the equation once you've substituted. For your values, use -1, 0, 1. So these here are input values. So I'm going to line them up right here. And we're going to get the y value. So here, that means I'm going to plug in. So I've got y equals 2 times -1 plus 6. So 2 times -1 is -2 plus 6 is 4. So my first y value is 4. So that means my ordered pair is -1, 4. Remember to put parentheses around the ordered pair. So if I'm doing the next one, I'm going to get y equals 2 times 0 plus 6. So 2 times 0 is 0 plus 6 is 6. So my next value is y is 6. Okay, so my ordered pair here is 0, 6. Now it looks like the pattern here would be increasing by 2, but let's do the last one just to make sure. So I'm going to have 2 times 1, which is 2, plus 6, which is 8. So, yep, the pattern was increasing by 2. So my next ordered pair is 1, 8. Now these directions also say to graph the equation. So let's go ahead and graph that. So our ordered pairs were negative 1, 4, 0, 6, and 1, 8. So we're going to go ahead and graph that. Actually, I'm going to just delete that. All right, here we go. So 1, 8. I'm going to go over 1 up to 8. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then I've got 0, 6. So I'm at 0, 1, 2, 3, 4, 5, 6. And then negative 1, 4. And once you graph the coordinates, it should form a straight line, and then you can connect that. Make sure you draw the line with arrows, and don't just connect the 3 dots, draw it across. So really, I should even extend this further across my graph because it's going to continue on and on. Okay, so let's try another example. Okay, so this time they're not giving us values for x. So let's add in our own, and let's make it a little bit more challenging. So we're going to say our x values are 2, 3, and 4. And you can always, if it doesn't give you any, choose smaller numbers to make it a little easier for you. So let's go ahead and work these ones out. So my rule is y equals negative 2. I'm going to multiply that by 2 plus 2. So negative 2 times 2 is negative 4, plus 2 is negative 2. So my first y value is negative 2, so my ordered pair is 2, negative 2. Okay, so my next one, I have y equals negative 2 times 3 plus 2. So negative 2 times 3 is negative 6, plus 2 is negative 4. And then our ordered pair is 3, negative 4. Okay, and our last one, we should probably expect it to be negative 6 because that looks like what the pattern is. So I have negative 2 times 4, which is negative 8, plus 2 is negative 6. So my last coordinate is 4, negative 6. So now let's go ahead and graph those. So I've got 2, negative 2, 3, negative 4, and 4, negative 6. Okay, so when I put these on the graph, they should form a straight line. So 2, negative 2, 3, negative 4, and then 4, negative 6. And you can see that it did indeed form a straight line. And then we connect them. You should use a ruler to connect yours to form a nice straight line, but I'm not really capable of doing that here. So that's what our line would look like there. All right, so here I've got 2 examples. Here's the first one, and here's the second one. Okay, and I would like for you to try to create your function table and then graph it. And then you notice I've even gone one step further, is we're going to list the domain and range too. So go ahead and pause the video and try to complete these two problems. Hopefully at this time you've paused the video, so let's see how you did. Alright, so you can see here that I use the numbers -2, -1, 0, 1 for the first one. And it's okay if you use different numbers, because when we connect this, your line should be about the same. Okay, and then our domain is here, so you might have different numbers for your domain and range. Okay, the second one over here, you can see my line looks like this. And then my domain is here. My range is here. So if your lines are roughly the same as mine, then you know you did that correctly. Okay, at this time you are ready to move on to your next assignment for today. If you have questions still, please make sure you get them asked.